All right, hello, my wonderful students. This is foldable number 3, part 1. This is 7.5, 7.6, modeling using exponential equations and logarithms. All right, so for the first one here we have, here we go. It says wood is sustainable, renewable, and natural resource when you manage the forest properly. Your lumber company has 1,200,000 trees. You plan to harvest 7% of the trees each year. How many will it take to harvest half of the trees? So we need to get to our target. So we're going to have, the first thing we're going to do is we're going to write our model. So I know our model we're going to use is going to be our, I guess we can use T because it's for the trees, equal to our AB to the N. I know our end goal, the T to the N that we want to get, our T to the N that we eventually want to get is going to be equal to half of this, right? Which is 600,000, because 600,000 is half of 1.2 million. Okay, that's going to be the model that we want. Now we got to find the variables. So we got to find our A, our B, and our N. Or the N is actually what we're going to be looking for, right? But we got to find our A and our B. Well, our A is our initial amount or principal. So our A is going to be equal to the initial amount, which is our 1,200,000 trees. And now we got to look for our B. Remember, our B is equal to our 1 plus our rate. And our rate is actually going down, right? So let me just do this in blue so it's a little bit differentiated. So our rate is equal to, it's 7%, but we're actually going down 7%. So it's going to be a negative 7%, right? Because that's how much we're cutting down every year, which is equal to a, or not equal to, but which translates to a negative 0.07% that we're losing, or that we're cutting down every year. So that means our B is going to be equal to our 1 plus our negative 0.07, which is going to give us a 0.90, oh, 93, not 97, 0.93. Okay, once again, I'll explain it again. So we're cutting down 7% of the trees every year. That means we're actually, when we take it, it's actually losing a 0.07. So when we're adding it to our B, which is going to be 1 plus our rate, it's going to subtract. And this is going to give us a decline, right? Because if we had anything here besides a negative, it would make it an exponential increase, but we're not, because we're actually cutting down trees. So we know it's going to be an exponential decay, okay? Not an exponential growth. All right, now that we have everything there, we can go ahead and put into our equation here. We have T to the N, which we don't know what N is yet. That's what we're going to be solving for. So we have our T to the N, which our T to the N was 600,000. So it's going to be 600,000 equal to our A, which is 1,200,000 times our B, which ends up being 0.93 to the nth power. Okay. All right. First things first, we're going to go ahead and divide by 1,200,000. Because remember, we're trying to solve for this n here, right? Get rid of this 1,200,000. Well, these are going to reduce to 1, and we're going to have 0.93 to the n power here equal to, we can just get rid of each of these zeros, and we have 6 divided by 12, which we know this is 1/2. Now we're going to go ahead and change colors. We'll go to red. We're going to take the log of both of these. So this is going to be the log of 1/2 equal to the log of 0.93 to the n. Now we can use the power rule and move this to the front. So we have the log of 1/2 equal to the n times the log of 0.93. Now we can go ahead and, I'm going to put this in parentheses because just in case it's confusing people, we can go and divide each side by these. So we're going to change to black. We're going to divide both of these, this one by log of 0.93 and also by here log 0.93, and this is going to give us our n. So our n is going to be equal to, so we got to put that in clear. We have parentheses log of 1/2 divided by the log of 0.93, close parentheses, and we get n is equal to 9.55. So now our conclusion, of course, is gonna, it's approximately, right? Because we don't, it's 9.5513375,094. But we're not gonna write all this down. So our conclusion is, so it will take about, and it was 9.55 years to harvest half of the, and there was 1,200,000 trees to start off with, so 1,200,000 trees. Okay, and that's what we answer. So how many years will it take to harvest half the trees? It will take about 9.55 years to harvest half of the 1,200,000 trees. Sorry, that's my Google app.